Hello dear students, so now today we would move ahead in this first chapter of class 9th mathematics, that is number system. So previously we have discussed some questions where we have discussed whether the given rational numbers have the terminating decimal expansion or not. We have discussed there. Okay, so on the basis of this I have written a new question here. Question is, look at the several examples of rational numbers in the form p by q, where p and q are integers with no common factors other than 1, having terminating decimal representation. Okay, now if you see, let me take some examples now. Let's say I have written here 1 by 2, 1 by 4, 1 by 5, 1 by 25. These are some examples I have written. Or let me write one more. I have written here 1 by 10 also. Okay, and let me write one more, 1 by 100 also. So these some sort of rational numbers I have written. Okay, now let me check whether their decimal expansion is terminating or not. Okay, now if you are dividing this 1 by 2, you are going to get here 0.5. It means terminating decimal expansion. Here if you are dividing, again you are getting 0.25, terminating decimal expansion. Here if you are dividing, again you are getting 0.2, terminating decimal expansion. If you are dividing it here, again you are getting the same decimal, you are getting 0.04, terminating decimal expansion. Again you are here, if you are dividing, you are getting 0.1, I think, isn't it? 0.1, yes, that is again the terminating decimal expansion. If you are dividing here, there you are getting 0.01, so again you have a terminating decimal expansion. So which kind of rational numbers have the terminating decimal expansion? Means what is the property that depends upon this one, the property of the denominator. So what should be the property of the denominator so that it could have the terminating decimal expansion? So we have to tell the property of the denominator, that is the q. This is p, this is q, p by q, isn't it? So we have to tell the property of the q so that it would have the terminating decimal expansion. On the other hand, if I write 1 by 3, I am getting 0.33333 etc. non-terminating. Similarly, if you write 1 by 7, again you are getting non-terminating decimal expansion. You just try to divide it, you will be getting non-terminating decimal expansion. So here, if you have the q in the form of 3, 7 etc., so at that time you are getting non-terminating decimal expansion, non-terminating repeating. But if you have the q in the form of 2, 4, 5, 25, 10, 100, then you are getting the terminating decimal expansion. So can you guess the property here? Yes. If q is in the form of 2, or in the powers of 2, or in the form of 5, or in the powers of 5, okay, or in the form of 2 multiply 5, so then only the given rational numbers would have the terminating decimal expansion. Now again, if you see here, it is 1 by 2. This is 1 by 2 square. Square of 2 is 4. So this I can write as 5. And this, the next one I can write as 1 by square of 5, isn't it? The next one I can write as 1 by 2 multiply 5, that is 10. The next one again I can write as 1 by 2 square multiply 5 square. Isn't it? 2 square is 4, 5 square is 25, 25 4 is 100. Isn't it? So now if you see, if the denominator is in the form of 2 raised to the power n, means in the power of n, in the power of 2. If the denominator is in the form of power of 2, the n can be 1 here. So if n is 1, then you have 2. If n is 2, then you have 2 raised to the power 2. If n is 3, then you have the 2 raised to the power 3. Then again you would be having the terminating decimal expansion. Remember, if denominator is in the form of 2 raised to the power n, then you would have terminating decimal expansion. If the denominator is in the form of 5 raised to the power m, then again you would have the terminating decimal expansion. Let's say m is 1. M is 1 means 5 raised to the power 1 means 5. You have the terminating decimal expansion. If m is 2, that means 5 raised to the power 2, that is 25. Again you would have the terminating decimal expansion. Okay. So if the denominator is in the form of 2 raised to the power n, 5 raised to the power m, or the multiplication of these, like here 2 raised to the power n, 5 raised to the power m, like here. If n is 1, m is also 1, then you have 2 multiply 5, that is 10. If n is 2, m is also 2, then you have 2 square multiply 5 square, that is 100. So in both the cases you would have the terminating decimal expansion. So the property of the denominator should be what? Either the denominator should be of the form of 2 raised to the power n, or it should be of the form of 5 raised to the power n, or it can be of the form of 2 raised to the power n multiply 5 raised to the power n. So if these things are there in the denominator, then you would have terminating decimal expansion. Remember this. Remember this. Let's say if I am writing 1 by 8. So now just tell me whether if you are dividing by 1 by 8, you would get the terminating decimal expansion or not. Answer is yes. Because if you just factorize it, you would be getting 2 multiply 2 multiply 2. 2 to the 4 to the 8. It means 2 raised to the power 3. That is what you are getting. So the denominator is of the form of 2 raised to the power n. Isn't it? So if the denominator is in the form of 2 raised to the power n, then it would have the terminating decimal expansion. You can just try it by dividing. Okay. So it implies what? It implies whenever you have the denominator is in the form of 2 raised to the power n only, 5 raised to the power m only, or 2 raised to the power n, 5 raised to the power m, then only you can have the terminating decimal expansion. Otherwise not. If you have 3 in the denominator or some powers of 3, then you would have non-terminating repeating decimal expansion. If you have the denominator as 7 or some other things are there in the denominator, then you would have again non-terminating repeating decimal expansion. Okay. So now we have guessed the property of the denominator. If the given rational number has to be in the form of terminating decimal expansion, so the property of the denominator is either the denominator should be of the form of 2 raised to the power n, or 5 raised to the power n m, or 2 raised to the power n multiply 5 raised to the power m. Nothing else. Nothing else. If you have the denominator like this, 6. So if you just factorize it, you would get 2 multiply 3. So just tell me, would it have terminating decimal expansion? Yes or not? Do not think here is 2. Here is 3 also. The denominator should have only 2 or only 5 or 2 multiply 5. Only these things should be there in the denominator. Other things should not be there in the denominator. But here you have 3. Isn't it? So it means this one rational number would have again non-terminating repeating decimal expansion because it has 3 in the denominator. Okay. So the rational numbers having in the denominator 2, 5 or their powers, then only such decimal or such rational numbers would have terminating decimal expansion. Otherwise they would have non-terminating repeating decimal expansion. So you have guessed the property, isn't it? Let me write this all. Okay, what is the property now? Property is what? The property of the denominator should be what? The given rational number would have terminating decimal expansion if it is in the form, if it's a denominator, if its denominator is in the form of 2 raised to the power n or 5 raised to the power m or 2 raised to the power n multiply 5 raised to the power m, then only it would have the terminating decimal expansion. You can take some example also. Let me give you. Just tell me 125. You are dividing 1 by 125. Just tell me if you are dividing 1 by 125, you would have terminating decimal expansion or non-terminating repeating. Just guess it. So for this you would have to factorize this. Just if I am factorizing this, let me 5 5 is 25, 25 5 is 125. So 5 3 times, so I can write it 5 raised to the power 3. It means the denominator is in the form of 5 raised to the power m, isn't it? So if the denominator is in the form of 5 raised to the power m or 5 raised to the power 3 is here, so hence it would have the terminating decimal expansion. So yes, you can divide it. after dividing you would get the terminating decimal expansion. Okay, let me give you some more examples here. Let me ask you, just tell me 1 by 80, would it have terminating decimal expansion or not? Just divide, just factorize this first. If you are factorizing, you are getting 2 2 ja 4, okay, 4 2 ja 8 and 8 5 ja 20. So again, if you see in the denominator, you have only 2 and 5. 2 raised the power 3 is there and 5 is there. It means the denominator is having only 2 and 5. If the denominator is having only 2 or only 5 or both 2 and 5, then only it would have the terminating decimal expansion. So here also you can see that the denominator is in the form of 2 raised the power n multiply 5 raised the power m. So hence again it would have terminating decimal expansion, isn't it? Let me give you some more. You can divide it. You can check your answer also. Now just tell me 1 by 30. Would it have terminating decimal expansion or not? Just factorize. 2, 3 ja 6, 6 5 ja 30. Now if you see, the denominator is having 2 and 5. But beside 2 and 5, it is having 3 also there. So it would not have terminating decimal expansion. Rather, it would have non-terminating repeating decimal expansion. You just try to divide it. If you are dividing 1 by 30, you would not be getting the remainder 0. Repeating things you would be getting there. Okay. So are you guessing the property now? Okay. So only those rational numbers would have the terminating decimal expansion which are having the denominator in the form of 2 raised the power n, 5 raised the power m or both. Other things would not be there. Right? Like here you have 3. So it would not have non-terminating. It would have non-terminating repeating decimal expansion. Isn't it? I think you are knowing now how to solve such question. Like previously I have given you many questions there in the previous one video. Okay, to find out their to express in the decimal form. So you would have got there. Some are in the form of non-terminating repeating decimal expansion, isn't it? So only those are having non-terminating repeating decimal expansion where the denominator is in this one form. You can check it there also. Okay, let's say you have 1 by 36. Just tell me, would it have, without dividing it, just tell me, would it have terminating decimal expansion or non-terminating repeating decimal expansion? Just factorize this. Just factorize it. 2 2 ja 4, 4 3 ja 12, 12 3 ja 36. Now if you see, the denominator is having 2, but it is having 3 also, isn't it? So it would not have terminating decimal expansion. Rather, it would have non-terminating repeating decimal expansion, isn't it? So without dividing also you can guess. Are you getting this? Now let me give you some examples for whom where you would have to tell me whether the given rational numbers are having terminating decimal expansion or not. Okay, so just find whether the given rational numbers are having terminating decimal expansion or not. Okay, some question I am giving you. First is 1 by 2 without dividing. Just tell me, would it have terminating decimal expansion? Yes, because it is having 2 only. So you would write there terminating decimal expansion. If I am writing 1 by 3, because it is 3 here, so you would write non-terminating repeating decimal expansion. Okay, so this is how I am going to give you many examples here that you have to solve on your own. 1 by 8, 1 by 16, 1 by 24, 1 by 26, 1 by 28, 1 by 38, 1 by 50, 1 by 58, 1 by 200, 1 by 500, 1 by 625, 1 by 324. So these are some rational numbers which I have given you, and without dividing you have to tell whether they are having terminating decimal expansion or not. So what you would do, you would factorize the denominator first. Then if the rational numbers having the denominator in this one form, then you would say yes, they are having the terminating decimal expansion. Otherwise, they are having non-terminating repeating decimal expansion, isn't it? Okay, that is all for today. Would be discussing some more questions of this chapter in the upcoming lectures. Till then, stay tuned and keep watching. Thank you. Have a good day.